This is Pre-Calculus Concept 38B. We're going to talk about evaluating some harder limits now, where you are required to use your calculator or know some other algebraic means that you'll learn. So let's look at our problem to start. I've got the limit as x approaches 2 of the following: x squared minus 4 over x minus 2. If you try what's called a direct substitution, let's do that real quick. On the top, you'd get 4 minus 4, and on the bottom, you'd get 2 minus 2. And the answer to that is 0 over 0. And that may seem problematic. It might seem like there isn't an answer to this question. Or it might seem like the answer is 0 or something like that. But it turns out none of those are true. There is an actual answer that you can find. We're going to start off by kind of examining how to think about limits on your calculator. So I have 4 screenshots here. You will need your calculator, so why don't you grab that. And Malia and Nick, this is especially for you. All right, so there's a couple things we have to do to get started. One is to type the function that we're using into your y equals. So as if you're going to graph it, you want to type that in. Parentheses are important with rational functions, so make sure your entry matches mine there. The next thing is to set up our table. If you've never used the table feature on your calculator, the first thing you're going to do is hit the button second and the button window, and that will pull up your table setup. The 2 is really important because that's kind of the value that we want to investigate. And your delta table is how you read that next line. We're going to start with 0.01. What that needs to be is some small number, and we'll use 0.01 to see what happens. And then you want both of these to be on auto. So one of the great features about your calculator, the table feature, is that it gives you lots of values of the function all at once. And so the way we've set it up, it's going to look for values at and around 2. So the first thing you may notice is that when I plug in 2, or I look at the value when I plug in 2, I get an error message. And that's not surprising because we got something that didn't really make sense when I tried to plug in 2. However, remember that with limits, it's all about the behavior near 2 and has nothing to do with the behavior at 2. So what you really want to look at in your results here is this pattern from both directions, and what it appears the y-list is getting closer and closer to. So regardless of you having an error message there, you should be able to see that the pattern is getting closer and closer to 4. So the answer to this limit is 4. All right, our last screenshot there is just a more specific table. So usually 0.01 or 0.001 is sufficient, but I did an even more specific table. You can see that the values get even more close to 4. And the idea is to kind of imagine that to infinity. So whichever way I look at my list, I'm getting closer and closer and closer and closer to 4. Therefore, the limit of this problem is 4. All right, let's try another example. I want you to kind of follow along on your calculator this time. So the first step of this one is to type that function into your calculator. Okay, should look something like that. Remember, parentheses are important, so the numerator and the denominator there should be in parentheses. All right, next step is to set up your table. Keep in mind that we are investigating the limit as x approaches 9. Think about what that means and set up your table. All right, the key thing here is that your table start is in the neighborhood of 9, and so mine has 8.99, which is very close, and that your delta table is a very small number. Again, you can use other numbers besides 0.0001, but you want to be sufficiently small, so make it a small number. Next step is to actually view your table, so see if you can pull up your table next. All right, and you should see something like this. Your table might look a little different if you use a different delta, or if you started slightly different, but basically you need to scroll around until you get to, you know what? Sorry, hang on one second. I pulled up the wrong screenshot there. So your screenshot should look something like this. And again, the key idea is we're investigating around 9. Even though I have an error message at 9, I do see a pretty clear pattern from either side of about 0.16667. Here's where you have to do a little bit of educated guessing. If you were to go even closer and imagine that number being even closer to something else, you would imagine that it would be 0.16 repeating forever. So your calculator kind of has to round because it can only hold so many digits, but that turns out to be 1/6 as a fraction, and that is our answer. And so even though this function doesn't exist at 9, it does have a limit as x approaches 9. All right, one more for you to try. See if you can do this one from start to finish. What is the limit as x approaches 2 of x cubed minus 8 all over x minus 2? All right, make sure you set your table up around 2, and again, a small interval around it. And when you see that, you should see something like this. And looking at these values, we should see that I get an answer of 12 for this one.